Here it is x raised to 1 dx. In place of n, here x raised to 1. X raised to 1 dx is equal to x raised to 1 plus 1 divided by 1 plus 1. That means x square by 2. Then apply the limits. First, in place of x, you will put the upper limit, that is x only. Then we will get back, this is equal to kx square divided by 2 minus k into 0 square divided by 2. This goes, we will get this is equal to half kx square. So this work is done. This much work is done in extending the spring to 0 position to, that means its equilibrium position to x extension. So this amount of energy, that is this amount of work done, is stored in the form of energy in the spring. Therefore, we can write the potential energy of the spring is equal to half kx square. Half kx square. So this is a very important relation. Potential energy of spring is given by U is equal to half kx square. The same thing can be derived in some other way also. This I am removing. That means the spring force is a variable force. So the work done by a variable force can be obtained by, what I said, by plotting the force extension graph. At different stages, then slowly, the spring is extended. And every time, with the help of a spring balance, you can use it. A spring balance is attached to the end of the spring and it is pulled. At different stages, the force applied by you on the spring can be calculated. Extension can also be calculated. So by taking different values of forces and different values of extension, plotting in a graph, you will get. That means this is the force along the y-axis and extension along the x-axis. When a graph is made, the graph will be a straight line. For all elastic bodies, this is the condition, right? Because F is directly proportional to x. So the graph between F and x will be a straight line like this. So this value, for this value, say suppose this is the extension of x, extension I will write. Extension I will write, okay? This is force F. Along this is force. For an extension x, the force is equal to F, but F is equal to kx. So this much is this 0. 0 to F and 0 to F. This can be given as equal to F, that is equal to kx, I can write. So this is the graph plotted between a variable force and extension. For variable force, the work done is obtained by taking the area under the force extension graph. In this case, what is the area? Work done by the force is equal to the area under this. That means a half base into altitude. That is a half into base is x into altitude is f. F is equal to kx. Therefore, this is equal again half kx square we are getting. So work done can be calculated as equal to half kx. This work done is stored in the form of potential energy. Therefore, we can write U. Potential energy is most of the time denoted by U. U is equal to half into k into x square. This is an alternative method also, I said, because spring force is a, it is not a constant force, it is a variable force. So at different extensions, the force applied is also different. That is why we say that spring force is a variable force. Work done by a variable force is calculated by plotting the force extension graph. Same relation will be got. In the integration method also we got half kx square. This method also we got half kx square. What is K? K is the spring constant of the spring. Am I correct? So if you draw a graph between potential energy of a potential energy stored in the spring and the extension produced at different values of extension, what is the value of at different values of extension? What is the potential energy? This one. That also we can say this is what is called the equilibrium position when no force is applied, right? When extension increases or extension decreases, I mean it's a compression or extension. Both the cases, the potential energy is increasing like this. Am I correct? Okay. That means when in the equilibrium position, the potential energy is equal to 0. When it is extended, potential energy goes on increasing. Right? Or when it is compressed, potential energy goes on increasing. Extension and compression, the potential energy goes on increasing. This is a graph between what? Potential energy, what is called elastic potential energy and extension. At different values of extension, the potential is stored inside the spring is different, can be shown by this graph, this parabolic graph. Am I correct? So this is the condition. This is a parabolic graph you are getting like this because u is equal to kx square itself is a parabola, right? Okay, that's why this graph is shown like this. So this is the graph between what elastic potential energy and extension. So this is the topic today I had to teach you, and I did it satisfactorily. I suppose that you understand everything. Tomorrow we will come with a new lesson. Till then, bye bye. Thank you very much.